All right, so for today, all right, we're going to try to zip through section 7.2 and 7.3. We also have a crazy week. All right, there's pictures being done. They'll make some announcements about that might interfere with some classes. And there's something going on at the end of the week. I'm not sure exactly what, but there's a broken week already. We didn't come back on Monday. All right. So I have to get things done. All right. Which means uh, I'm trying to really get you ready for high school. So I really need you to concentrate, try to do a good job. If you weren't happy with your grade, just change what you're doing. If you're happy making a B, then just continue what you're doing. All right. I'm totally fine with that. All right. No pressure to make A's. All right. I want you to make an A, but if you're happy doing what you're doing, that's perfectly fine. All right. So now for this, number one, determine whether each pair of figures is similar. If so, write the similarity statement and the scale factor. The similarity statement is just relating the two triangles. I'll show you what that means. The scale factor is just how many times bigger is it than the other one. All right. So in this case, 59 and 35. So if two angles of one triangle are congruent to two angles of the other triangle, then what's true about the third angle? It is congruent. Do we have to say what the angle measure is? No, we can just say we know that angle B is congruent to angle E. That they even had that as a theorem. It was called the third angle theorem. All right. So now we just have to determine if the sides are proportional. Now it's a little bit harder to see the sides are proportional because the decimal. Do we agree with that? So here is the easiest way, in my opinion, to do this. Write them from small to large. For example, the big triangle, I'm going to write a 6, 9, and then a 10.5. On the other triangle, it has to be what? Smallest to largest again, 4, 6, and 7. Everybody see that? And now you're just saying, if those fractions are equal, then I know that the triangles are similar. Now, of course, 6 over 4 is the same as what? 3 over 2. 9 over 6 is the same as 3 over 2. Now, for those of you guys who are not happy with doing division, which I never was, so I avoided division at all cost. When I have 10.5 divided by 7, when I have decimals, I just doubled it. 10.7 times 2 is what? 21, and 7 times 2 is what? 14. All right, now it's easier for me to reduce the 21 and the 14. What is 21 and 14 reduced to? 3 over 2. All right, so are the triangles similar? Yes, the triangles are similar. The triangles are similar because all the corresponding parts are, or all the corresponding sides are proportional and the corresponding angles are congruent. So from there, we can say A, or I should say triangle ABC is similar. The symbol for similar is just the little squiggly line. And then that would be similar to what? Triangle DEF. Right. And now we need the scale factor. The scale factor is the ratio. All right. The scale factor is 3 to 2 or 1.5. You could say that the large triangle is 1.5 times the smaller triangle, or you could say the smaller triangle is 2/3 of the large triangle. Do we agree with that? All right. In other words, if I were to multiply 6 by 2/3, I would get what? 4. If I'd multiply 4 by 1.5 or 3/2, I would get 6. Everybody understand that? All right, so now let's look at question number 2. What is that shape called? Nope. Well, I mean, it is a parallelogram, but it's a rhombus. Thank you. You should know that is a rhombus. All right. Now, Are the angles congruent? Are the sides proportional? Therefore, it is similar, right? So here again, we can say that rhombus, and then we're going to label it PQRS. PQRS is similar to WXYZ. And now, of course, it is 3/7.5. And you can see what I'm saying. Doubling makes it 6 out of what? 15. And then we can reduce it by 3. So we would say the scale factor is 2/5. The small one is 2/5 of the large one. Do we agree with that? Or the large one is what? No, not 2/5 more, 5/2. All right. In other words, if I were to multiply this by 5/2, I would get what? 7.5. Is everybody hearing me? Right. So the ratio is either 2:5 or what? 5:2. Is everybody understanding that? All right. So the larger one is 5/2 the smaller one, or the smaller one is what? 2/5 the large one. Does everybody agree? All right. Now here it's saying that the shapes are similar. So now we have to figure out what X is. All right, let's not waste too much time here. All right. What is the relationship between the larger and the smaller? Yeah, the smaller one is what? Or you could say the larger one is 2 times. You see how I'm not arguing over this. When I say what's the relationship, your answer could be what? Either 2 or what? 1/2, depending upon how you're looking at it. All right. In this case, I like to say, well, we're starting with the large one and then the small one. So I would have looked at that and said the scale is 14:7, which is what? 2:1. All right. So it's just twice as big. All right. Since we're looking at X, though, we now can just say X is what? 6.5. There's no work in that. All right. I don't think that's difficult. All right. So here we go. Let's go to the next page. All right. Now, if you want, at the top of the next page, this is the introduction to 7-3. All right. This is the introduction to 7-3. Now, there are 2 ways to prove triangles are similar, and today is the first way we're going to show you, which is just angle-angle similarity. And this only applies to what? It only applies to triangles. All right, think about a square and a rectangle. Are squares and rectangles similar?
Yes.
Wait a minute now, I didn't say is a square a rectangle or a rectangle a square. I just said if I draw a square and then I draw a rectangle, are they similar?
No.
No. The angles are equal. Do we agree? Right. So I'm trying to impress upon you that triangles, if the angles are congruent, then it's automatically what? Similar. However, does that apply to other shapes? No, just the triangle. An example I gave you was a square and a rectangle. Those all have equal what? Angles. But are the sides proportional? Definitely not. All right, are definitely not. So a square and a rectangle are not similar. Just because they have equal angles does not make them similar. The only shape that holds true for is a what? Triangle. All right. So as soon as you can recognize that 2 angles are congruent, then the triangles are similar. All right. So let's take a look at this over here. So for question number 7, angle B would be what? Do we agree angle B would be 60?
Yeah.
Now, are they similar? There's a 60 and a 58, a 60 and a 58, correct? So we would say they are similar by angle similarity. So now they want you to write the similarity statement, which is just saying triangle ABC is similar. Now notice A is the what? 58 degrees. So it has to be to triangle what? Z. B is the 60 degrees. So Y, and that would be X. The angles have to line up. All right, the angles. It was always easy for me to just look at the angles and write the similarity statement based off the angles. Everybody's good with that, right? All right, so let's look over here. All right. Now it says, determine whether the triangles are similar. Is LMN similar to LPQ?
Yeah.
How do I know? Or how do I not know? What is the only way we know to prove triangles similar again? Angle. So we agree that angle L is corresponding to angle L, right? Is M congruent to P? How do I know? Well, how do I know they're parallel? That's a good point. What if it was 8 and 16? What do you mean it's not? But just because it says 8 and 12, what is 8 and 12? Why is that special? Is there any way to tell, is the question is? No, it doesn't say that these are parallel. If these are parallel, then are we good? Yes, because then we can use, those are corresponding angles. But it doesn't say they're parallel. All right, so bear with me on that. You can't say just because it looks like it. All right, so these are not similar. Not similar. Now you see the difference here, correct? Do we have parallel lines? So we know that L is congruent to what? P. And we know that M is congruent to what? Q. And of course, these are vertical angles. So now we know they are proportional. So now I need some help setting up this proportion, please. Go.
Plus 3 x minus 1. And then would it be 18 over 12?
Yes, I like that. All right. Now notice x plus 3 is between 1 and 2. Do we agree with that? X minus 1 is between 1 tick mark and 2 tick marks. Everybody agree with that? 18 is between what tick marks? And so 12 is also between what? Now they can throw you off easily just by twisting the shape and twisting the triangles and flipping them and doing all kinds of things. Everybody with me? That's why I like to label the angles and say the side is between these tick marks. So x plus 3, you're supposed to tell me, corresponds to what? X minus 1. Does everybody agree with that? And 18 corresponds to what? 12. Now, whenever you have 18 over 12, save yourself some time. What could I do to 18 over 12? Yeah, reduce it. So we could just say x plus 3 over x minus 1 equals, yes, 3 2s. That sounded great, Jocelyn. All right, now just make sure we cross multiply. So we end up with 3x minus 3 equals 2x plus 6. So x must have been what? 9. All right.
Checks out.
And then LM would be what? 12. Don't forget to answer the question. LM is what? And then QP is what? 8. Anybody have any questions with that? Okay, now you'll understand what I'm saying for question number 10. All right, are those parallel? Yeah, so are the triangles similar? All right, now please, you got to watch up here because this is the one that everyone makes a mistake on. All right. So ML corresponds to what? ML.
LN.
ML corresponds to what? No. Man. Oh, wow. I didn't do a very good job. Here we go. Look up here, please, and make sure you're hearing me. I just said ML. That corresponds to what? NL. Whoever said that, thank you very much. NL. Do we agree with that? And then we would say KL corresponds to what?
J.
JL, correct? So when you're writing this proportion, you can't just put numbers down. All right, it's got to be in specific order. All right, so if I say, if I say 6x plus 2, that's the right side of the triangle. Do we agree? Over the right side of the triangle. What's the right side of the big triangle? Say it again. No, it is not x plus 5. That's the mistake everyone makes. The whole length is 7x plus what? Now look, if you're starting finally to pay attention, right? These are the details that I try to tell you. You miss if you're not paying attention, right? It's the top triangle, top small over the top big. All right, so I have 6x plus 2 over 7x plus 7. Now I did the small triangle. Now I have to do the what? The large. So we're doing small to large. So the small bottom part of the triangle would be what? 16. What's the large? Now you see how I think this is just a great question, because if you're not paying attention, you'll just put down letters and numbers. Everybody understand that? And of course, what can do with 16 over 24? Just make it 2/3 and make the problem easy. Now, when you cross multiply, distribute. All right, so 18x plus 6 equals 14x plus 14. So what do I end up with? 4x equals,
X equals 2. 8. Yeah, X equals 2.
did anybody else get x equals 2?
Yeah.
All right, so now NL, what is NL going to be? NL equals 21, and I need help with ML. 14. All right, is everybody good with that? All right, I'm trying to see if there's anything harder. Okay, so let's do this indirect measurement. All right, a mailbox casts a 4-foot shadow. A nearby tree that measures 12 feet casts an 18-foot shadow. Believe it or not, that's how they used to measure things. All right, using proportions. All right, so here is what we have. And over here, you just want to make the two triangles. All right, so the first triangle, the mailbox casts a 4-foot shadow. Let's make sure we understand the shadows on the ground, right? The shadows on the ground. All right. A mailbox casts a 4-foot shadow. All right. And then a nearby tree measures 12 feet. So this is 12 and this would be 18. All right. We're trying to figure out what the height of the mailbox is. Should be the other way, but whatever. So here, all right. Now, our proportion then, of course, would just be 12 over 18 equals X over 4. Or there's another way you could write it. You could just say 12 over X equals 18 over 4. We agreeing with that? There's so many different ways of writing the proportion. I don't really care. I just care what the answer is. All right, so you can have several answers or several possible answers for the proportion, but we understand if we solve this out now, then the height of the mailbox would be what?
48 over 18.
Can someone tell me what the height of the mailbox would be? Come on, come on, come on. 48 over 18 is not an answer. What?
6 feet.
Well, I don't like 2.6 feet. Just leave it as a fraction. She said 48 over 18. Her only mistake is she didn't reduce it. What is 48 over 18?
8 over 3.
Yes, 8/3 of a foot. 8/3 of a foot. If you want to say 2.2 2/3 feet, I don't care about that either. All right.
So the proportion would be
Either one of these you can set as the proportion. Yes, KK.
That the tree was 12 feet, but how did you get?
It
like, how
casts,
does 12 and 18 feet?
it says a 12-foot tree casts an 18-foot shadow. You with me on that? So that has to be the same as that proportion.
But how do you like is the tree like? How do you know that the shadow was like 12 feet? You know, it says it measures 18 feet. So how does it-
Okay, maybe I'm not clear. Here, look at this. Do you see it says the shadow's 18 feet? So here's 18-foot shadow. This shadow over here of the mailbox is 4. You with me? All right. I think I'm pretty good now. You should be able to finish this up, set up the proportions, solve them out. All right. I don't think there's anything hard. All right. The the moving shadows is interesting. I'd like everyone to try that. All right. Make sure you're good. All right. Welcome back. It was a great day. Yes, all of this is homework. You're welcome. You should be almost done. It's just setting up a proportion. Cross multiply, divide. Welcome back. Is this all we have? Good luck.